So here we are demonstrating a wireless IoT temperature and humidity monitoring system along with buzzer indication, and also locally we are going to monitor the humidity temperature on 16:2 LCD screen, as well as we are going to continuously monitor the same parameters like humidity temperature through IoT on blink cap directly. And here to send the data to the blink cap, we are making use of ESP8266 module, and which will send the information to the blink app through the internet service provider. For that we need to enable the hotspot before switching on this switch. I will explain you that later. So let us see the power flow. So we are going to provide the 230 volts input to this cable, and it will be stepped down by the 230 volts to 12 volts by help of transformer, and then 12 volts AC is input to this regulated power supply board. On this board we have placed the 4 diodes. So the diode purposer which will convert the AC to DC, and that will be the pulsating DC. So as we know that bridge rectifier will provide the pulsating DC, and those pulses will be neutralized with help of this capacitor, the 1000 microfarad capacitor. After that we will get pure DC of 12 volts, and that is the main input to our Arduino Uno. When it will get the 12 volts power supply, there will be a 1117 regulator which will provide the 3.7 volts, which is sufficient to run the microcontroller instructions inside this Atmega 328P controller on this Arduino Uno board. So then it will start reading input from the input modules like DHT11 sensor, and which was connected at 8th pin of our Uno board. And also, if is there any abnormalities, like if the temperature is higher than the 45 degrees or humidity is higher than the 80 percentage, then it will provide the buzzer indication here, and also will indicating the same thing on the gauge formation in the blink cap. And we have interfaced the buzzer at 13th pin, and Wi-Fi module at 0 and 1 pin, and LCD module at pin number 2 to pin number 7. So from here we are going to distribute the 5 volts power supply for the buzzer and Wi-Fi module as well as LCD module. So coming to this buzzer board, there will be one transistor. So the microcontroller Arduino Uno will trigger the transistor, and the transistor will trigger the buzzer. So in this manner, the buzzer is a 5 volt operated piezo buzzer, and this one is a ESP8266 module, and 16:2 LCD display, and this potentiometer to set the contrast inside the LCD. So before switching on this switch, we need to install the blink application, and log into the blink application with the given credentials, and go to hotspot settings in your phone and change the hotspot name to project 4736 without any capital letter and without any space, and password should be 123456789, and thereafter enable the hotspots. And now you can see that the device is offline as we get the red mark here, and when the device is got power supply, and then the system will get the welcome message on the LCD screen, and also the device will be online, and it will start sending the data to the blink application. Right, you can see that. Okay, so we can try with by changing the humidity just by blowing the air. Right, you can see that the humidity and temperature will be increased, and whenever it crosses the 80, then you'll get the buzzer indication over here, and we can see the same status on our blink application continuously. So till the humidity comes down to below 80, then the buzzer will be off. Actually, no need of buzzer for 80% of humidity. For demonstration purpose only, we set the limit for lower level. Generally it is 95 or 92 like that, and temperature also 45 degrees.